I'd like to do some examples here involving almost scientific notation, things that are close to being scientific notation but not quite. And these examples are going to involve the metric system. Here's one that is almost scientific notation. Suppose you have the number 530 and you've got a km there. Now the metric system has ways of dealing with units and multipliers of those units. The m here would be meters, and when you have a unit like this, there's a prefix that can show up on that, and this prefix means kilo. And in this case, kilo is the prefix, meters are the units, and kilo in the metric system happens to mean something particular. It means 10 to the third. So if I have that 530 km there, what it means is 530 times 10 to the third meters. And this is what I mean by almost scientific notation. Scientific notation should always be a number that's between 1 and 10, multiplying some power of 10. Well, 530 is not between 1 and 10, but I can convert it into scientific notation. If I write it as 5.30 times 10 squared, that's the 530. Now I've still got times 10 to the third meters here, and so now I combine these two parts and I'd have 5.30 times 10 to the fifth meters. By the way, I don't know for sure that I can keep that 0 as a significant figure. It would be better practice to actually write this as 5.3 times 10 to the fifth meters. That I know for sure. I have that much precision. But this is a way of converting that 530 kilometers into 5.3 times 10 to the fifth meters. Now I actually have the number in scientific notation. And there might be a reason that I need to have meters instead of kilometers. Another example of doing this is if I have the number 0.673 millimeters. Okay, now the meters are here. They're both m's, but the one to the left is always the multiplier. The one to the right is always the unit, unless it's a two-letter abbreviation. We won't go into that here. Anyway, I've got meters for units. The prefix on that, this m in the metric system, means 10 to the minus third. It means milli. So what I have here, that 0.673 millimeters, is actually 0.673 times 10 to the minus third meters. Okay, so 0.673 times 10 to the minus third meters is almost scientific notation. I've got to fix it though. I have to write this, what I have underlined here, as a number between 1 and 10 and a power of 10. And what I'd get is 6.73 times 10 to the minus 1. I still have a times 10 to the minus third and a meters here. Now I can combine these two. 10 to the minus 1, 10 to the minus third, that would be 6.73 times 10 to the minus fourth meters. And I've converted that 0.673 millimeters into scientific notation with just plain meters. And I might need that number for some particular reason. Let's do one more. We'll start with this, 543 nm. This might be a wavelength of light, for instance. This would be just about in the middle of the visible spectrum in the green area. nm, the N means nano, the M means meter. Nano is a metric prefix. It means 10 to the minus ninth, or 1/billionth of a meter. Okay, so that 543 nanometers, 543 times 10 to the minus ninth meters. And we're back here again to having almost scientific notation. The 543 I would convert to 5.43 times 10 squared, and I'm multiplying that times 10 to the minus ninth meters. These two, I can add the exponents and get 10 to the minus seventh, and so now I have 5.43 times 10 to the minus seventh meters, and that's what 543 nanometers would be. And I might want that to be in meters instead of nanometers. Okay, those are some examples of converting almost scientific notation into scientific notation.